Hello, it's Scott Manley here. It's January 31st and it's time for another batch of deep space updates. I'm going to try to make these weekly this year, but we'll see how that goes. Anyway, we're going back to 23rd of January. Kinetica 1, that's a Chinese rocket, third flight of it. It launched out of Jiuquan in China. The payload was 5 Taijing Earth observation satellites being launched into a sun-synchronous orbit. So yeah, Kinetica, it's like a 3-stage solid rocket that'll put 1.5 tons into low Earth orbit. 24th of January, we had another SpaceX Starlink launch, 22 satellites from Vandenberg. We had a lot of issues with the live stream. I tried to catch it. I was hoping it would be delayed, but no, it went off. The live stream was interrupted. A few people apparently saw it in LA. And the 28th of January, Iran finally has a successful launch of its Simorgh rocket. So Simorgh is like a mythical giant bird from Persian mythology. And it's all liquid fueled, unlike the solid fueled rockets that have been developed by the Revolutionary Guard. This is the civilian side of the Iranian space program. And this has not had a great deal of success. They've been trying to launch these since like 2016. The first launch was a success, but that was not a complete launch vehicle. Since then, every single launch has been a failure, maybe 4 or 5 failures depending upon who you talk to. But finally they got a success with 3 small satellites, Mada, Kayan and Hatef. So yeah, like just quick history of the Simorgh. The first launch was a success in 2016, but that wasn't to orbit. Then in 2017 there was the second stage failed. 2019 the third stage failed. 2020 it reached 6.6 kilometers per second, which is about 1 kilometer per second too slow. 2021 they got within 250 meters per second of orbit, and today, yeah, this week, whatever, they finally reached orbit. So, congratulations at last. Yeah, the rocket is about 87 tons. First and second stages are liquid-fueled hypergolics, and the third stage is solid for insertion. Okay, back to the US. We had back-to-back Starlink launches on the 28th from the East Coast and the West Coast. 23 Starlink into Group 6 out of Florida. And then 22 from Vandenberg. And again, I saw this. It was worth noting, by the way, that the Vandenberg launch cadence should be a lot faster this year because they were able to turn this launch around using just one barge relatively quickly. We're expecting something like 40 launches out of Vandenberg, and they have to pick up the pace, but I think it's possible that they do this. Okay, 30th, we had the launch of Cygnus on a Falcon 9. Now, Cygnus, of course, is Northrop Grumman's cargo vehicle to the International Space Station. It's originally designed for Antares, but it's flown also in an Atlas V after the first version of the Antares failed. The second version of the Antares then took over, and it didn't fail so much as be no longer viable into modern political climate, considering that the first stage is built by Ukraine with Russian engines. Yeah, so right now we're expecting Firefly to be building the first stage for Northrop Grumman, and I've certainly seen parts of that, or what could become parts of that. But for now, it's flying on SpaceX's Falcon 9, and it was a successful launch to the International Space Station, and they'll be berthing it, I think, in the next 24 hours. Also, 30th, we had Electron Rocket Lab launching 4 satellites for Spire Global. Yes, their lemur CubeSat. So the mission was called 4 of a Kind, and it's actually 4 satellites for a company called North Star, which are going to do space situational awareness, basically cameras that are going to look around themselves on orbit, trying to track satellites and space debris and other stuff. Spire are like a global satellite information company, and their satellites are called the lemurs, and it's something like low Earth multi something or other receiver. But the idea is, right, the low Earth multi-user receiver, that's it. And the idea is these payloads, they carry, like, they can listen to GPS, they can listen to marine traffic, AIS, and now they can listen to ADS-B from aircraft. And one of the cool things they do with GPS is they watch GPS satellites basically as they set behind the Earth, and as it goes, the beam comes through the atmosphere of the Earth, they can make measurements, and they use this to actually build atmosphere models. So, as I understand it, the satellites were referred to as Lemur 2s, but they are primarily these space situational awareness satellites for North Star, so I think they do both things, and essentially Spire provide the chassis and the know-how and the build, and they also get a little bit of data from this. So anyway, that being said, this was a fantastic launch to watch. Rocket Lab were going to go for a reusable flight, and the cameras were able to basically track the booster through almost all of its flight. We got to watch it separate, reorient itself, and then begin the descent through the atmosphere. We saw a bit of flaming, a bit of hot plasma. We got to see a parachute deployment and a touchdown. And we've since seen images of the booster as it has been recovered by a ship. So this is looking great for Rocket Lab, because they might actually be able to start getting some of that reusability that they've long talked about. So that's all the orbital launches. There was one other launch that's sort of notable, and that was Virgin Galactic. They flew 4 passengers this time. So we had Neil Kornsveit, Robbie Vaughn, Lisa Borzdina, I don't know, from Ukrainian American, and Austrian Franz Hader. So this is actually somewhat significant for Virgin Galactic, because this is the first time they've actually flown 4 passengers on the back instead of 3 passengers and a host astronaut to make sure they're safe. This makes a lot more sense for them financially, because it means they can travel, carry 33% more passengers. Of course, wouldn't it be great if you could fly up front with a pilot? That's what I'm waiting for. Okay, so that's the launches. Now on to the rest of the news. So, got to start out with SLIM. Now, last time we talked about this on Deep Space Updates, it had soft landed on the moon, and we weren't really sure the status. We did get a big update on it. It confirmed my assessment that it was nose down on the moon with the solar cells pointed the wrong way. And just a couple of days ago, finally we got enough power on those solar cells to start getting images and data from the moon. Also, LEV-1 woke up as well. It was apparently shut down because of high temperatures. So we started to get some data back. Japan will be able to claim that they performed extensive operations on the moon. However, since then, the sun has set, and the amount of data they've brought down will have to be this. We may get it back in, 24 days or so, given the orientation of the solar panels, but I won't be surprised if it's completely dead. Yeah, we did see some more images that came from the lander, or from its onboard cameras. An image of the toy poodle rock that was the first one that they pulled down, and there's another image showing the terrain as the sun got low. The other piece of news that I've also covered in a separate video is Ingenuity, the Mars helicopter, or Little Chopper as I like to call it, made its last flight, suffered a problem. We've seen that the blades are damaged. Now, we've only seen 2 of the blades and they've damaged, but given that these things spin really fast, it's probably all 4 of the blades that are damaged. We did have a press conference today where they confirmed that they are going to perform some tests. They're going to try rotating the blades very slowly, see if they can get image, from the shadow to see how damaged those are. They might turn them at some slightly faster speed, but they're not going to be able to fly this, right? I mean, sure, they might have lost only the outer 1/4 of the blade, but think about it. When you've got rotor blades, the outer part is the part that is moving fastest, and that's going to be generating more of your lift. It's sweeping out a larger area. They're not going to be able to take off again, and the thing will probably shake itself apart. I would really like to see it do some fast spinning to see if we can see triboelectric effect at night. That would be cool. That's an experiment that we haven't done, but yeah, I don't know. Time is going to run out because the rover has been navigating fairly quickly, and it will be passing it by in coming months and leaving Ingenuity in the Martian dust. So moving onwards, New Glenn. This is actually something I should have mentioned in the previous deep space updates. New Glenn has been seen out and about. Now, we previously had a mass simulator to give us an idea of the size. This looks almost like a flight article, and I would have thought that if it wasn't for all the places where we see not for flight or not flight hardware written on it. So this is it looks like a complete booster. It may or may not have engines attached. It looks like there's some plumbing. It's missing the fins that will be needed. And it rolled around on its chassis, to verify they can drive it around. Now, I think that this is probably not flight hardware, but they may go through like dress rehearsals with this to verify that the ground service equipment mates with it, verify that they can actually load propellant in and load up other gases and power it up. Were also images that were given out that showed the second stage mated to the first stage, and that's great. It means that they've pretty much got a whole rocket there, because we have actually seen their giant fairings. That was one of the first things that Blue Origin showed off. So I don't think this one's going to fly. I think there's probably another one in there somewhere. Somebody did also point out that one of the pieces of hardware had the name Rushmore, which I think would be great if Blue Origin would perhaps rush more. Moving onwards, Sierra Space performed a spectacular full-scale pressure test of their LIFE module. That is, Large Integrated Flexible Environment. This is basically an inflatable space habitation module that they want to fly. And so one of the requirements is that it has to handle something like 4 times atmospheric pressure, or 60 psi if you speak American, 400 kilopascals. And they brought it up to pressure on the test stand and burst it, and we got some cool slow motion video of this thing breaking. Now, funnily enough, they had a longer video that explained the testing of this, and they initially failed to perform this test because ground hardware broke under pressure, and that is a great vote of confidence, right? If you're trying to squeeze air into this thing and the thing squeezing the air in breaks before the flexible module, that's a good sign that that module is being built tough. Yeah, inflatable habitation modules. We have got the Bigelow expandable activity module on the space station. It's small, it's performed just as expected, but Bigelow, of course, have gone out of business. But we now have other companies that are coming along and may actually see larger things flown in space. And this will, of course, be part of the Orbital Reef project, which will be with Blue Origin. Also, sort of along with this, we saw Sierra are getting ready to place the Dream Chaser in launch configuration on a vibration test stand. So, it's getting real. Dream Chaser is about to go vertical, getting ready for some of the tests before it actually heads to space. In Europe came news that I have long been waiting for, right? There's a project called LISA, right? The Laser Interferometer Spectral... Wait a second. I don't know what it stands for anymore. Right, LISA, right? This is a gravitational wave telescope which uses 3 satellites orbiting the sun, and they remain roughly 60 degrees away from each other throughout the orbit. The idea, of course, is this is a gravitational wave telescope, and they are able to have really huge arm lengths. On Earth, we have LIGO, and those have 4-kilometer arms on them. Imagine this, you're going to have hundreds of thousands of kilometers of arms, even bigger, millions of kilometer long arms. These things are going to be able to detect gravitational waves that are down at extraordinarily low frequencies. So while the LIGO, the current gravitational wave systems, are able to detect the chirp as 2 black holes spiral down into each other in the final moments, these, LISA will be able to detect black holes spiraling much further out. And they are going to be able to predict when this is going to happen. We're going to be able to make sure that we know where this could happen and have all the telescopes ready to watch these cataclysmic events. So The reason why I said that this has been long awaited is I heard about this project back in the very early 1990s when I was at the University of Glasgow. We were still talking about gravitational wave as a theoretical thing that could be detected, and there were scientists at Glasgow working on this. And LISA was projected as to be like the next step, going out to space. 30 years it took them to get to this stage, and that included in 2015 launching a spacecraft called LISA Pathfinder. And that was able to demonstrate the performance of the optics and of the test masses to show that they could actually get the performance, the instrumentation that they required to make this constellation a reality and make it able to perform as it needed. So I'm very excited for that, but that is probably still next decade before we actually see it fly. Okay. Northrop Grumman, they announced that its satellite refueling standard is being adopted by the US military. So they have something called the passive refueling module that was partially funded by the DoD. And the idea is that you can refuel satellites, and you needed a standardized docking port with plumbing in it so that you could refuel the satellites. Now, they made a big thing about this. They have a space logistics company, of course, and they've already serviced satellites in geostationary Earth orbit using the mission extension vehicle. They want to fly a refueling vehicle next year, which will be set up to actually refuel satellites in space, and you carry like a ton of propellant in geostationary orbit to refuel satellites. Now, apparently their announcement was taken as Space Force is exclusively going to use this hardware. And a lot of other companies that were working on similar things requested some clarification. And yeah, there is still plenty of options out there. This is just what has been accepted as a first step. But hey, it's now going to be built into a bunch of military satellites. And so I can see where the standards are going to go. But hey, your commercial markets, there's possibilities for other solutions out there. Over in Spain, PLD Space, if you remember, they launched a suborbital recoverable rocket called Miura. They've got 14 million euros from the Spanish government to develop the Miura 5, which will hypothetically be an orbital rocket using the same recoverable booster concept. So now it's technically a loan that they've been awarded, that if they actually make money, they have to pay it back. And, well, that would be great if they end up having to pay that back. Look, small satellite launch market is, it's not the most economically viable, but I think it's nice that somebody's putting up some money for small companies to actually develop this technology, because we all know that it sort of feeds into the general healthiness of the tech sector in that area. So yeah, congratulations to you guys. I hope you do great stuff with the money you've got. China, they've announced that Chang'e 7 will be landing at Shackleton Crater, and that will be a huge coup because, of course, the US has been talking about going to Shackleton Crater with the Artemis program and everything, but looks like China is going to get there first. Now, of course, Shackleton Crater is significant because it's one of those places on the moon which has permanently shadowed regions. That is, places where the sun never reaches, and therefore we expect cold traps where ice might be found. And so Chang'e 7 is going to include like a lander, a rover, a flyer with instrumentation specifically to detect volatiles. However, should make it clear, it's not going to land in the permanently shadowed region. It's actually going to look for a permanently sunlit region, or at least sunlit through a lot of the lunar day, so they can perhaps maintain operational performance on this thing for much longer. This week, there's a conference going on in San Francisco, Photonics West. It's all about lasers and stuff. And the little tidbit that came out of that might interest you is that someone from Starlink was there, Travis Brashears, and he talked about Starlink's laser performance, their inter-satellite links, specifically saying that between the 2.3 million customers that Starlink services, they are transferring via lasers 42 petabytes per day, which is pretty impressive. There's over 9,000 lasers that they are shooting around and sending data around. But it gives you an idea of how big Starlink is becoming, that little tidbit that they delivered. Also in the last 24 hours, Starlab, they announced that they're going to use Starship and Super Heavy as a launch vehicle. So Starlab is the space station concept, which is being used for the commercial low Earth orbit destinations. It is a collaboration between Voyager Space, which is NanoRacks, and Airbus. So they're going to be building, it's instead of a pressurized, inflatable station, they're going to be building a solid walled station. And they think they can launch a single station on top of a Starship/Super Heavy combo and make a pretty good match. I mean, basically they'll be able to launch something the size of Skylab, 1/3 of the International Space Station, in a single launch. And that is kind of a big deal to make sure that there are customers for Starship to make it a viable launch platform. I remember talking about how when the Soviet Union collapsed, they were trying to sell all their launch services, and they had Energia, and they couldn't find any customers, and they dropped the prices to like something ridiculously low. Nobody had payloads that could match the capabilities of Energia. That's why it never flew again. But if they had, if we had the payloads, if we had the imagination, it would have flown. And that's why it's important to have these big payloads get pitch themselves as being a super heavy payload. Finally, earlier today, we found out the names of the astronauts which have been selected for Crew 9. That will be launching later in the year, probably around August. So we're going to have Commander Zena Cardman. Yeah, she was a new astronaut selected in 2017. Pilot will be Nick Hague, and you probably remember him because he flew on, I think it was Soyuz MS-10, which had the booster separation failure resulting in in-flight abort. He ultimately did fly in space and returned, and when he returns to space later this year, he will be the first active member of Space Force to be in space. Finally, Stephanie Wilson rounds out the NASA crew, and then from Roscosmos, you will have Alexander Gorbunov. So that'll be much later in the year. Obviously, we have Crew 8 that's going to fly before then. And but in the next couple of days, we should see Axiom 3 returning from space. That'll be something to look forward to. Wish them the safe returns. Until next time, I'm Scott Manley. Fly safe.